because I got inside of doing work during class. This fan hot. All right, we are going to wrap up this section today. We just have a few questions to go over on page 134. I know a lot of you were left early yesterday for the field trip, but I'm going to kind of recap what you guys missed. It's nothing really new. Okay, we've been talking about these concepts so far in this section. One of the big things from yesterday was we found that if a divisor goes in evenly, okay, when we do our synthetic division process, that means we have a remainder of 0, okay, nothing left over, so it goes in evenly. And if a divisor goes in evenly, we specifically call it a factor, okay, something that can be multiplied to get the dividend in the end. So if something goes in evenly, it's called a factor. And then if it is a factor, we know that factors of polynomials give us the x-intercepts, aka the zeros of a graph. So if we can figure out the factors, we can figure out the x-intercepts, basically where the graph touches or crosses the x-axis. Okay, so we're going to take a look at some of those concepts today. On page 134, we're just going to go through a few examples. At the top, if x minus 1 is a factor, okay, so they're telling you it goes in evenly into this polynomial, what are the other two factors of g of x? And then rewrite it in factored form, like your little groupings, okay? What's a little neat about this, and we're going to get into this in the next section or two, do you realize how this polynomial is cubic? It has that power of 3, okay? That's kind of cluing you in that you should probably have 3 factors. You are multiplying 3 things together. So if they're already giving you 1 factor, maybe we can figure out the other 2, okay, since it's a degree of 3. And we kind of did this at the end of the day yesterday. If we know 1 factor, we can go through the synthetic division process, and if the divisor goes in evenly, then so does the quotient, okay, or the answer part that you get back from division. So what we're going to do is we're going to synthetically divide this divisor by the dividend, and then we're going to take a look at the quotient and see if we can factor that a little further. Okay, figure out the other factors for the polynomial. All right, so what would be our little box number in this case? If x minus 1 is our factor? Yeah, 1. All right. All right, so then let's go ahead and use the coefficients from the polynomial, aka the dividend. And we'll continue through the synthetic division process. Does that synthetic division kind of confirm their statement? X minus 1 is a factor. See how it goes in evenly? We have that remainder of 0. So what we're going to do is we're going to take the quotient, which are the other numbers down below, and we have to put the x's back into them. That way we can factor it a little further. So if we were to put in the x's, what would the quotient look like based off of these numbers? Go ahead, Sarah. Minus x minus 3. Okay. So what we're going to do is we're going to think about our factoring techniques. We already know the divisor goes in evenly, so that means the quotient does as well. We can factor that a little further. So looking at our quotient, how might you want to try to factor it? Yeah. There we go. A times c add up to b. So we have negative 6. We've got to multiply 2 and add to a negative 1. Can we think about those values? Yeah? Negative 3 and a positive 2. Okay, so at this point you guys have those, or you have the option. We can either do divide and slide, or we can do by grouping. Do we have a preference? No? I like divide and slide personally, okay? So maybe we can do that for this one, okay? If you guys don't care, that's what I'm going to do. Okay, so Emily said -3 and a +2. Okay, so divide and slide. We're going to divide those values by the A coefficient, which was 2. Notice how 3 divided by 2 does not simplify, so we can slide the 2 in front of the x. But 2 over 2 does simplify to 1. Alright, so now we know all 3 factors of this polynomial, and we're going to rewrite g of x in factored form. Okay, the one they gave us at the top is standard form, nice order of terms, no parentheses, no groupings. Okay, so if this is standard form, okay, we're going to rewrite g of x in factored form. So we should have 3 factors, because we kind of had that power of 3 at the top. The first factor, let's not forget about it, was the x minus 1 that they told us from the very beginning. And then we used that factor to help us figure out the other 2 by going through synthetic division and some factoring. And we found those other 2 to be 2x minus 3 and x plus 1. Alright, so we just transformed standard form into factored form by knowing one of the factors. Okay, I think if you tried to maybe do grouping on the standard form, like not even go through the division process, you would eventually get here as well. But sometimes, even though you have 4 terms, grouping might not work. Okay, but going through the division process will always work to help you figure out some other factors. So this one's a little neat because you could check your work by grouping and see if you get these answers as you factor. So if you wanted to try that on your own, you could. Okay, let's go ahead and try the next one. If x plus 2 is a factor of that polynomial, what are all of the zeros, aka x-intercepts? Okay, so this one's kind of similar to the one we just did. It's just that we're going to take it a step further. So once we know what the factors are, we can utilize those to help us figure out those x-intercepts. So it's still the same process as before. Okay, we're just going to go ahead and find those x-intercepts afterwards. So what would be our little box number for that divisor? Are we thinking -2? I see pencils moving, so you guys are doing it, right? Okay. Alright, so once you guys synthetically divide, notice how we have a remainder of 0, so we know x plus 2 is a factor, it goes in evenly. We can take the coefficients from the quotient, put those x's back in, and think of some factoring techniques. Yeah. There we go. A times c add up to b. All right. So we got to multiply to -12, add to -1. Can we think of those? Yeah. -4, +3. Okay. So do we want to do divide and slide again, or we want to try the grouping process? If you guys don't care, you know what I'm going to do. Divide and slide? Okay. X, let's see, we said plus 3, right? -4. Okay. Let's see, divide 2. We get 2x plus 3 and x minus 2. Okay, so if we were to rewrite h of x this time, that's what this new polynomial is polynomial is called in factored form. We would need the x plus 2 that we started with. Okay, people always seem to forget that one. Okay, you always start with one at the beginning and then you're finding out the other ones. So we have x plus 2, 2x plus 3, and x minus 2. So based on those factors...
Excuse me, interruption. I need senior's last name G through K to report to the cafeteria. G through K.
Okay. Based off those factors, we should be able to figure out graphically where those zeros or x-intercepts are. Can we figure them out? Can we list them? If you were to individually think about which x value would make each factor 0, let's see, we would need a negative 2 from the first factor. We would need a positive 2 from the last factor. Those are kind of the easy ones. What about the middle factor? Yeah. A negative 3 halves, yep. Okay, so there are your x-intercepts. We doing okay so far? All right, let's tackle 7. For what value of k is, okay, so if you look at the wording, this is when it gets a little confusing. For what value of k is the factor x minus 2 a factor of the function? You see how they use factor twice? Okay, factor does mean divides in evenly, okay, a remainder of 0, but factor can also mean just a general term meaning a group of items or a group of terms. So this first factor is just telling you that this is a divisor. If they're asking you if it is a factor, this factor means goes in evenly. Okay, we know how the English language is kind of tricky, where you have the same word can mean like 2 different things sometimes. Okay, that's what's kind of going on here. So they're asking you for what value of k is this divisor essentially a factor. Okay, does it go in evenly for that particular function? How might you want to try that? How can we test to see if something goes in evenly? What should we be looking for if it goes in evenly? Good, Marie? A remainder of 0. Okay, so we know something special about the remainder. How can we perhaps use that remainder of 0 to help us solve for that missing coefficient? Like, what does this k have to be in order for this divisor to go in evenly? What do you want to try? Yeah?
Don't we say equal to 0 and plug in 2 for x?
We can use the remainder theorem. Okay, we talked about 2 theorems in this section. The remainder theorem tells us if we were to take the 0 from the divisor and plug it in for all the x's, we should get an answer that represents the remainder, what would be left over. And since we know, or at least we want it to be a factor, we could set this equal to 0. Okay, that's one of the theorems we talked about. The other one from yesterday was the factor theorem. Okay, if a divisor goes in evenly, we know it has a remainder of 0. Okay, kind of common sense, but it technically has a name called the factor theorem. So let's go ahead and take that little box number of 2, and we'll plug it in for those x's. Some of these numbers might get a little large, so if you have a calculator handy, you can go ahead and use it. If not, we can try to do it in our heads. Might take us a little bit longer, but we'll give it a shot. Let's see, 2 cubed is 8. 8 times 6 is 48. 2 squared is 4 times 19. I think that's 76. Plus 2k plus 6. So negative 70 plus 48. I think that's negative 12. Is that checking out? Negative 22, I was off by 10, sorry. Okay. So let's see, we can add the 22 over and divide by 2. I think that looks a little better. Okay, so in order for this divisor of x minus 2 to be a factor, aka go in evenly, the k value must be 11. If it's anything else, it won't divide in evenly, so it wouldn't be a factor. Okay, so that's utilizing the remainder theorem, something we talked about a few days ago. Okay. Do you guys want to try the next one? Take a look at 8. Kind of similar question. How does negative 16 sound? Pretty good? Good job. All right, let's take a look at the last one. Is x plus 1 a factor? If so, how many times? Okay, so let's take a look at just the first question here. Is x plus 1 a factor? We got to determine, does it go in evenly, aka does it have a remainder of 0? How do you want to test that? We kind of have options. Do you want to take the value of negative 1 and plug it in and see what we get out? Okay, if we get out 0, right, doesn't that represent the remainder? Okay, or you could actually go through the synthetic division process, because notice how we don't really have a k in here that's throwing off synthetic division. We have nice coefficients to use. Okay, we have options there. So let's think about which one of those two might be a little bit better for us to utilize. There is a second question, okay? If it is a factor, how many times? Okay, so how many times does it go in evenly? So we got to first figure out if it does, and then if it does, how many? Think about this. If I were to ask you, is 2 a factor of 18? Would you say yes or no? You don't have to write this down. I just want you to think about it. Does 2 go in evenly into 18? Yes. But how would you want to figure out how many times? What else do we got to look at? Yeah. We got to look for division. Okay, so we know how many times does 2 go into 18? 9 times. Okay, 9 is considered the quotient, right, or the answer from division. How many times does 2 go into 9? 4. Does it go in evenly, though? Remember, is it a factor? How many times is it a factor? Does it go in evenly? Does 2 go into 9 evenly? No. So 2 is a factor of 18 just once. That's how many times it evenly goes into it. Let's check out, maybe that was a little bad example. Let's try, we'll do 12. Is 2 a factor of 12? Yes. How many times? How many times does 2 go into 12 evenly? 6. How many times does 2 go into 6 evenly? 3. How many times does 2 go into 3 evenly? It doesn't. So you notice how 2 was a factor twice here. It went in evenly 2 times. So what we got to do is look at this division process. Maybe the remainder theorem isn't the best way to go here, because we're going to take a look at the quotient, okay, the answer from division, and keep analyzing that. Okay, how many times does it go in evenly from there? So let's take our little box number of -1 and the coefficients from the polynomial, and we'll do our first division. Is x plus 1 a factor? Yep, it goes in evenly. Okay, so right now it goes in evenly once that we know of. But what we got to do is we got to take a look at these quotient values and see, can we go another round of this division? Okay, will it go in evenly again? So we're going to take the same box number of -1, but this time the second round of synthetic division is going to utilize the quotient values. Is x plus 1 a factor again? Yes, okay, so it goes in evenly twice so far. Let's see if we can keep going, okay? We're going to take the same little box number, and this time use the new coefficient values from the quotient. See if we can go another round.
Excuse the interruption. At this time, I need those seniors' last name M through R to report to the cafeteria. M through R to the cafeteria, please.
Is it a factor again? Yep, so far it goes in evenly 3 times. Okay. Let's check another round. What about our last round? Does it go in evenly? Not quite, okay? So this x minus 1 factor goes in evenly 3 times, okay? It shows up 3 times if you were to write it out in factored form. So we'll say x plus 1 is a factor 3 times. I hope the little number example helped make that make sense. Okay, when you keep analyzing the quotient, taking it further and further until it doesn't go in evenly, that's what we're doing with the synthetic division. Okay, we're taking the quotient coefficients and just keep going around after around until we don't go in evenly. Are we doing okay? Perfect. All right. We still have about 5 minutes left if you guys want to tackle some of the homework problems. I think we covered a lot of different questions or types of questions that can be utilized for these factor theorems and remainder theorems. So go ahead and kind of use a lot of those questions we did in this section to help you with the homework problems. They're very similarly worded.